Okay, now that we're done with chapter 2, let's look at chapter 3, which involves alkenes and alkynes. Okay, the alkenes will have double bonds, the alkynes will have triple bonds. Okay, so you're gonna have a double bond here, you're gonna have a triple bond here. You are shown an example of limonene, which generally has a general structure of menthol that is used to soothe lozenges or coughs. So we'll talk about much about these double bonds and triple bonds and their hybridizations and refer to their planarity and their shapes. And of course, later in the chapter we'll talk about their reactions. So a double bond will have one sigma bond, one pi bond. Okay, one will be pi, one will be sigma. A triple bond will have a sigma bond. On top and the bottom, you'll have a pi and a pi. Okay, so triple bond has a sigma bond and has two pi's. They are unsaturated because they don't contain the maximum number of hydrogens, and they are also known to be olefins. This is an archaic name of alkenes and alkynes. They were called olefins, but we disinherited that name. Okay, so general formula for alkenes, so to review, was CnH2n plus 2, where n is number of carbons. For alkenes will just be 2n. You lose 2 hydrogens, you'll be left with 2n. To move from alkenes to alkynes, you're gonna lose 4 hydrogens, so it will be 2n minus 2. All right, so these ones are unsaturated. Why? They have less hydrogens. Those hydrogens are replaced by pi bonds. Okay, so there is what we call index of hydrogen deficiency that gives us an idea of how much pi bonds we have. It's also going to give us the number of rings possible in a molecule. But I think I'm not gonna dwell much on IHD calculation for now until we do spectroscopy, if we get there or when we get there. So the double bonds can be arranged in different patterns in a structure. If the double bonds are next to each other, like connected, that's cumulated. Okay, if they are alternating with a single bond, then that's gonna be conjugated. You have conjugated diene and you have conjugated diene, because you have two alkynes. 2 triple bonds is diene, 2 double bonds is diene. Where you have at least 2 single bonds separating the pi bonds, that's isolated, right? They are far away, so they are isolated. So you see there are 2 single bonds there, you have 3 single bonds here. Those are isolated systems. The one that's gonna be very, very stable is gonna be the conjugated system because of resonances. Okay, all right, so how do we name alkenes? Typically, instead of prioritizing substituents, giving substituents the least number possible, for example, here you'll want to number from this way and not this way, so the substituent will be a 2 and not a 4. Instead of prioritizing substituents in alkenes, we prioritize the pi bond before the substituents, and we'll have to use ene at the end of the name. Of course, the general formula is CnH2n. I already talked about that. The longest chain is going to be determined, and again, you have to prioritize and give the first carbon of the double bond the lower number possible. Follow other UPAC rules used in naming alkenes. Remember, whenever you have italicized sec butyl, for example, tat butyl, the di, tri, tetra substituents, their first alphabets are ignored whenever you're writing the final name of the molecule or in determining the alphabetical order. But the prefixes iso, neo, cyclo are not ignored. We consider the I, N, and C. If the same number of alkene functional group suffixes obtained, in either direction, then we have to name to give it the correct name which contains the lowest substituent number. Okay, if the substituent numbers are not helping, maybe there's a tie, then we'll have to use the alphabet rule. For example, E for ethyl and M for methyl. So I've said too much, but let's now practice. Remember again, our priority is to give the double bond the least number possible. So for this molecule, this is the longest chain, and I really have to start here. I repeat, this is the longest chain containing the double bond. Okay, you have to find the longest chain containing the double bond. So I have to start here because again I'm prioritizing the double bond to have the double bond, to have the first carbon of the double bond having the least number assignment possible, rather than starting from here 1, 2, 3, 4, 5, 6, 7, 8. See, the first number of the double bond here is 7 versus 1, so 1 wins. Now, one would have said the longest chain is 6, 7, 8, 9, 10. It's 10 carbons going straight out, straight to the right or straight to the left. You would count 10 carbons. But that's not the longest chain of the alkene. The longest chain of the alkene should be the one that contains the double bond. And the correct numbering is the blue because you're prioritizing the carbon of the double bond before you look at the substituents. Now, this will be considered a substituent because it's popping out of the longest chain, which is in black. It has 4 carbons in it, so it's a butol. Okay, so the UPAC name for this molecule will be 3-butyl because the substituent is on the 3rd carbon. You have 8 carbons on the longest chain, so oct, and then the double bond position must be specified, is on the 1st carbon, oct 1, then in, referring to alkene. Alright, so let's do more examples. So what will be the name of this molecule? So to name this molecule, we have to find the longest chain containing the double bond. That's the first rule. So it's 1, 2, 3, 4, 5. You could either go 6 down or 6 up. Then this becomes our substituent, or you could decide to name it from number it from the right. So it's 1, 2, 3, 4, 5, 6. We really want to give our double bond the least number possible. The first carbon of the double bond should be given the least number possible. So between the red numbering and the blue numbering, the red will win because you get a 2 versus the 4. So you are prioritizing the double, not the substituent. If you prioritize the substituent, then the blue will win because it gives the substituent a 2 versus the 5. So the correct numbering is the red one again, because the rule states that you have to prioritize the double bond and give the first carbon you encounter while numbering the least number possible. The first carbon of the double bond should be given the least number possible. So here the blue numbering is wrong. So the correct name will be, we have a substituent on 5th carbon in red, and it happens to be a methyl. So it's 5-methyl, and then the double bond is on the 2nd carbon, 2, and then you have 6 carbons, the longest chain contain the double bond, hex. It's an alkene, so in. So that's one version of the name. The other version of the name will be 2-methyl, and it's also true. And then we say hex, and then this position where the double bond was found with the least number, you put it here as an infix, hex 2 in. So these two can come before the parent name, or the position of the double bond, the two can come within the parent name. Both of them are acceptable. Alright, so how about this one? I would name it as 1, 2, I'll number it as 1, 2, 3, 4 in red, or I'll number it as 1, 2, 3, 4. Now there's a problem here because you realize in blue you have a 2 as the least number of the first carbon of the pi. In red you have a 2, so the numbering is not helping for the double bond location. So we go to the second priority, which is give the substituent the least number possible. It so happens that our substituent right now popping out of the chain has 1 carbon, so it's a methyl. Now if you look at numbering in blue, the numbering in blue, it gives the methyl position 3. The numbering red gives the position 2. So the red numbering wins in this case. The position of the double bond did not help us like it did in the first example. So we use now our regular rule that we use in alkenes. Give the substituent the least number possible, so the red will win 2 versus 3. So the name for this will be 2-methyl. Okay. 2-methyl, and then but, because you have 4 carbons in the longest chain, and then define the position of the double bond 2, and then it's an alkene, so 2 in. Alternatively, you will give it the name 2-methyl 2-butene, where the 2 is a prefix of the parent name. Here the 2 is an infix of the parent name. All right, what if you have this structure? So what if you have this structure? So let's number in blue 1, 2, 3. We are finding the longest chain containing the double bond, 5, 6, 7, 8 in blue, and then you could number it from here 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so in this case, this becomes our substituent. It happens to be an ethyl, and this becomes our substituent. It happens to be a methyl. Okay, now let's find the numbers for the double bond. That's the priority number 1. If double bond position is not helping, we look at the least number position of the substituents. If the least number position of the substituents is not helping and there's a tie, we go with the alphabet rule to decide which numbering system is correct. So looking at the blue numbering, I have a substituent at 3 and 6. So 3 and 6. So if you sum up those positions, actually that does not help. I think let's repeat. So the double bond here, going with the blue, the first time you encounter the double bond is at 4. Going with the red, the first time you encounter the double bond is at 4. So that the position of the double bond is not helping. Going with the second prioritization of looking at which is the correct numbering, we look at the least position of the substituents. I have a substituent in blue at 3 and a substituent at 6. Sum up, you get 9. And then I have a substituent in red at 6 and a substituent at 3. Sum up, you get 9. So again, it's not helping. The locant position of the substituents is not helping. The position of the double bond did not help. The substituents are not helping. So now we go with the third level of prioritization to check and decide which is the correct numbering, which is the alphabet rule. M in methyl comes after E in the alphabet. Okay, in the alphabetical order. So in this case, now we'll have to go with the alphabet rule and choose E. So the correct answer numbering will be the red one because it gives the ethyl at 3 versus the 6. We are going with alphabet rule because the position of the double bond did not help. There was a tie. Position of substituent did not help. There's a tie. Now we're going with the alphabet rule. So E comes before M. So the red numbering is correct. The blue numbering is wrong for this molecule. So the correct UPAC name will be 3-ethyl 6-methyl and then I think you have 8 carbons in the longest chain, so oct, the double bond is found at this carbon 4, oct 4 in. Alternatively, you could name it as 3-ethyl ethyl 6-methyl 4-octene. So the position of the double bond could be within the parent name as an infix or just before as a prefix on the parent name. You have to define always the position of the double bond. What if you have this molecule? Now this time you have 2 double bonds. Okay, so let's number from this way, and this is gonna be the correct numbering because it prioritizes the double bonds. This is the double bond on the outside, so you really want to number from this way to give at least that double bond the least number possible. So you have the double bond at 1 and 3, so the parent name would be 1, 3, and then pent, because there are 5 carbons in the longest chain, penta, diene, because there are 2 double bonds, so we say diene. Okay, and then we have a methyl on 2 and 4, so the part of the name will have 2,4-dimethyl. So now combining these two, the correct name will be 2,4-dimethyl and then 1,3-pentadiene. Penta because it's 5 carbons. We include the A this time around because it's a diene. And then di because you have 2 double bonds. In because they are double bonds. In refers to double bonds, so diene, 2 double bonds. Alternatively, the name would have been written as 2,4-dimethyl pent 1,3-diene. So when there are 2 double bonds is diene, when there are 3 double bonds is triene, and you have to specify the positions like I did here, 1, 3, 1, 3. Alright, so what if you have cyclic alkenes? What would be the name of a cyclic alkene? So let's start with this molecule. Again, we have to prioritize the double bond, so you have to go through the double bond. Okay, so it's either you do that or, like I said, you have to go through the double bond, or you say in blue 1, 2, 3, 4, 5, 6. Your priority is the double bond position. If it's not helping in numbering, then consider the substituent. If the substituent is not helping, consider alphabet rule. Now, if you look at the numbering, the double bond has 1, 2, 1, 2, so it's the same, so that's not helping. So we look at the substituent. It seems like the metal will get a 4 versus the 5, so the black numbering is correct. So the name of this molecule will be 4-methyl, and then the double bond, of course we are going with the black numbering, 4-methyl 1-cyclo, because it's a ring. The ring has 6 carbons, so we say hex. It's a double bond in there, in. So it's 4-methyl 1-cyclohexene. Now, what if you are given this molecule to name? Okay, so this time our substituent is an ethyl. Like I said, prioritize the double bond position, so you either start from here or here because the molecule is symmetrical. Let me start here. Go through the double bonds. You don't start here and go the other way around. You have to go through the double bond. You prioritize the double bonds. 1, 2, 3, 4, and 5. So the name will be 5-ethyl, and then the double bond is on position 1 and position 3 the first time you encounter the sp2 carbons of the double bond. Okay, so it's 5-ethyl, 1, 3. Okay, we specify the position of the double bonds, and then you say cyclo because it's a ring, and then it's 5-membered ring, so penta. Okay, because there's 2 double bonds, that's why I'm saying penta. Others would have said pentene. Penta, then di to specify the 2 double bonds, and then in, diene, 2 double bonds. All right. So what if you are given this structure? So where would you start if you're given this structure? In fact, let me put another method here. I would tell you that if you have 1 double bond and there's a substituent, that's where you want to start. Give that double bond, the carbon of the double bond with the substituent, priority 1. And then, of course, you are prioritizing the double bond over the substituents right now, or over in the ring, so that will take 1. You have to go through the double bond again, 2, 3, 4, 5, 6. I insist, each time you have to go through the double bond in these rings. So the name here will be, because you have 2 methyl groups, so you'll specify it as 1,5 and then dimethyl. Okay, 1,5 dimethyl, and then the double bond, first time we have a double bond is on 1, and then cyclohexene. In fact, most authors ignore the position of the double bond whenever it's just 1 in the ring, but I want you to get all the details right. So it's 1,5 dimethyl, 1 cyclohexene. Now if you are given such a molecule, now the position of the double bond will not help you, because if you start here, it will be 1, 2, 3, 4, 5, and 6. So you can go either way. Okay, you can start here or start there. But now, because there's no telling which side you should start from, because the molecule has 2 double bonds and they are across each other, you cannot use the substituent location, because one could have even started from here and say this is 1, 2, 3, 4, 5, 6. Either way, the substituent location would be 1, 5, 1, 5. So the other trick is just to use the alphabet rule to decide where which sp2 carbon is. The first one, obviously the E comes before M in alphabet rule, so the blue numbering is correct. So the name of this compound will be 1-ethyl and then 5-methyl. Always list your substituents in alphabetical order in the official name, in the final name. 1-ethyl, 5-methyl, and then you have the double bonds on 1 and 4. So 1, 4, and then it's cyclo hexa because there's a double bond. That's why there's 2 double bonds. That's why include the hexadiene. All right. So now for alkynes, we'll follow the same system, only that you'll use Y and E in the suffix part of the name, and your general formula for alkynes will be CnH2n-2. For alkenes, it was CnH2n. This was for alkenes. For alkenes, it was CnH2n plus 2. So for alkynes, we subtract 2. the rest of the rules applies. You going to prioritize the position of the triple bond. You find the longest chain containing the triple bond and give that triple bond the least number possible, like we've been doing for alkenes. So let's do a few examples. So what if you're given this molecule, which can just be drawn like this? What would be the name? Okay, let me modify it and just make it longer, a little bit longer. So if you number it from here, it will be 1, 2, 3. There's a carbon here. It's this carbon not shown. Whenever you have a triple bond, the beginning and the end of the triple bond, there must be a carbon. That's a catch. So I have 7 carbons, okay? 1, 2, 3, 4, 5, 6, 7 carbons. That is in red. In blue, the numbering will be 1, 2, 3. There's a carbon in there. 4, 5, 6. That's the 5th one. And then 7. So which of this numbering prioritizes the triple bond? Obviously, it's the blue numbering, because you encounter the triple bond sooner at 3 than in red, where you encounter the triple bond at 4. So the correct numbering is blue. The red is out. So the name of this molecule will be 3, because there's no substituent. I just start with the position of the triple bond, 3, and then there's 7 carbons, so it's hept. It's an alkyne, so I put Y and E, 3-heptine. So what if you're given this molecule? What will be the name of this molecule? Okay, what will be the name of this molecule? Again, you prioritize the position of the triple bond, so the correct numbering will be from the left. There's a carbon in here and in here. 4, 5, 6, 7, 8. Okay, so the name of this molecule, because we have a substituent, we have to start with the name part of the substituent, and it's 2 of them. There are 2 of them. There's one at the 2nd carbon, another one at the 7th. So it's gonna be 2,7 dimethyl, because there are 2 metals. Okay, and then we specify the position of the triple bond, because there's no more substituent, 3, and then there's 8 carbons in the longest chain, so oct, and then there's a triple bond, so ine. Alternatively, you could call it 2,7 dimethyl, and then oct 3 ine, using the position of the triple bond as an infix. Here it's prefix, here it's infix. So either of these is correct. All right.